different system there. Now after different sessions, then what will happen with respect to this is, see, after processing that one, then again the combined result will be gathered and as well as it is returned back so far. So that actually we can make it out in this Hadoop there. But these kind of the things actually you have to do that. Then see, what are the things we have to do here is, see, we need to have two components. See, here we have in Hadoop actually we have see, to process this in Hadoop we have two components known as HDFS, and next I have here is map reduce. These are the two components we have with respect to this Hadoop there. Now what is actually the HDFS stands for? See, we have here is Hadoop distributed file system. HDFS stands for, see, we have here Hadoop distributed file system so far, and map reduce we have with respect to this programming there. Now what will happen is, if you want to perform any kind of the administrative task so far, that actually you can do with respect to this HDFS there. Now if you want to perform any kind of the programmatic task, like as I told, Java code you have to write, these kind of the things actually you have to do, then we need the help of this map reduce so far. So that's why, see, here what will happen is HDFS is coming with respect to this administrative things, where map reduce is coming with respect to this program there so far. So these kind of the things. But as I am telling, see, what will happen is, whenever we have to perform these kind of the operations, then we need to know about this Hadoop architecture. What is actually the Hadoop architecture so far, and as well as what are the things are available in this, those we have to see it out here. Fine. So see, first coming into the, see, Hadoop architecture, see, we have here, see, what are the main things we have here is, see, so what is actually the HDFS there, and what is actually this map reduce so far, and as well as what are the components actually we have with respect to this there, and how actually this process is going to happen with respect to this, that we have to see here. Fine. So let us see in the HDFS what will happen is, see, here is, see, in HDFS, if you want 4,000 computers to work on your data, then you had better spread your data across the computer. So that's why HDFS will perform that one. Because see, if you want to divide any task across various computer client systems, that actually we can make it out with respect to this HDFS there. Okay. And in the same way, next I have here is map reduce so far. See, what will happen, this is a programming model for Hadoop, and as well as in this we have two phases we have. So first we have here is map, and second we have here is reduce. So like that, these are the two phases we have. Now if you want to perform the data, by means, see, first you have to map the data with respect to this, and as well as return the values, like programmatic things actually you have to do that, then we need the help of this map reduce there. So that's why we have HDF, these kind. So that's why, see, what we have to do, that any kind of the programmatic operations, map reduce will take care of that. Any kind of the data maintenance as well as data splitting of the data, these kind of the things you have to do, that HDFS is going to take care of these things. But actually, see, these are the things actually you have to make it out. What are the different things are there? Because see, here I have with respect to this is we have we need to know that what are the components actually we have with respect to this, that we have to see. So in this, see, these are the components we have here. So HDFS contains, see, Hadoop contains different components known as. So what are the different components actually we have with respect to this Hadoop is, see, we have here is, first I have here is name node, and as well as next we have here is data node, and next I have here is job tracker, and as well as next I have here is task tracker. These are the four components we have here. Fine. So that's why in the Hadoop we have this, and fifth component is their secondary name node, that we are not taking it out with respect to this. So these are the operations we have to make it out. These are the four nodes we have. First we need to have this name node, and next we have here is data node so far, and next I have here is job tracker, and fourth one we have here is task tracker. So like that, these are the four components we have here. Fine. Now in this, see, what will happen is, see, we have name node and data node are falling under HDFS, where job tracker and task tracker are falling under map reduce so far. So in HDFS, name node and as well as data node are falling with respect to this, and where in the job tracker and as well as task tracker are falling under this map reduce so far. Now see how actually this working of this one is going to happen out with respect to this. See how actually it will happen with respect to this. By means see it has this HDFS and as well as those things we have find. Now how actually it will work, because see what is the job of this name node and as well as what is the job of this data node, and what is actually this task tracker, and what is actually the what is the job of this task tracker, and as well as what is the job of this mm, job tracker, that we have to see right now. So see here we have here is, so that kind of the thing actually you have to make it out. Then this is the architecture it will implement. First it will implement in such a way that see first we have the different components like this. So the main Hadoop is coming with respect to this as master node and as well as child nodes like this. So first we have here is, assume that this is a master node we have here, fine. So this is a master node we have, assume that. So now in this C master node, what are the things we have see with respect to this C in the master node C we have here, and next we have here is some of the child nodes we have here, fine. So this is the child node 1. So these are the things we have. So first we have here as this is a master node we have, and this is we have child node 1, and as well as this is child node 2 and child node 3 and 4. These are the different nodes we have. Now what will happen is, see here what will happen is, what is the job of this master node C we have here is, whenever any task comes, it is going to divide the task into this equal number of partitions, and as well as it will send to this child node so far. So in this, so that's why see as we discussed 4 components are there now, which will be there in each of the things. Let us see here. See so in the master C we have here is, we have 2 components as C we have. So master contains these are the following components as job tracker, and as well as next we have here is name node. These will be there in this master node so far, and as well as C we have here is task tracker and as well as data node. These will be available in this child node so far, fine. And data node, these are the things we have. So this is the way the architecture is defined with respect to this. So in the master node, what are the things we have is, we have job tracker and as well as papa just a second. Yeah, so see this is the architecture we have here. So first we have here is in the master node, see first we have here as job tracker and as well as name node, where it is in the child nodes we have here as task tracker and as well as data node. These are the things we have here, fine. Now after that, see here what will happen is, how the way it is going to work it out and what is the working process we have, and these are the things first we have to see here. So how actually this these nodes are going to work it out, let us see first. So see, coming into this, the working process, see, we have here is, see, the applications which are running on Hadoop first contacts the master node. So any data first you are going to tell, it would be coming into this master node first. So far fine. Then what will happen? One of the main attributes of Hadoop is batch processing. So that's why it sends the request to the master node in queue, and once the task is completed, and it would be informed to the applications, and the result will be given to this application, because master node is only responsible for so master node is only responsible for this communicating with the applications, because whether, but it has to get the data from this corresponding child node so far. So now in the master node, see, as we discussed, there are the two components we have here, isn't it, as job tracker and as well as data tracker. So like job tracker and as well as name node, so like that. So what is the job, what is the role of this job tracker? See, we have here, you see, as I am telling that, see, whenever any big task is coming, by means lot of data is coming there with respect to this, then what we have to do that, we have, so whenever any data is coming with respect to this, see, first what is the job we have to do, that we have to break the task, as I am telling, that actually can be done by this master node so far. So that's why, see, the role of this job tracker component is break the bigger tasks into small pieces and send the task trackers which are in the slaves. So after that you have to combine the mm, yeah. So that's why, see, we have here is the role of this job tracker component is to break the bigger tasks into this small bigger tasks into the small pieces and send the task trackers which are there in slaves so far fine. And after that, what we have to do here is we have to combine all the results into a single unit and send back to the job tracker so far. So automatically it has to send to that. Now those are given to this application so far fine. So that is the job of this job tracker so far. So if you want to break this yeah, so that's why, see, here what will happen is the role of this job tracker component is to break the bigger task into the small pieces and as well as send the task trackers which are there in the slave so far fine. Okay, now next thing, see, coming into this, we have what is the name node we have. Now whenever we are making this task into this different thing, so see here what is happening there. See, I'm telling, for suppose if I have 100 requests are there, assume that, just a minute, assume we got 1000 requests from application, then what will happen? What is the job of this what is the role of this job tracker? Assume, so here, see, we have assume we have 1000 requests from the application, then what will happen? See, we have, what is the role of this job tracker? See, we have, then job tracker divides the task into equal, just a second. we have assume we have 1,000 requests in the application. See, then what will happen? Job tracker divides the tasks into this equal number of partitions. So, and sends to the child nodes. So that is the job of this job tracker. So far fine. And all the requests are processed. Then it combines all these and sends the data back to the client application. That is the job of this that is the job actually we are going to make with respect to this job tracker so far. Now in this C we have here is done what is the role of the name node, but whenever we are making these partitions na, then I have to maintain the index, isn't it? Which child node is doing all the things, so that actually the index needs to be maintained. That thing can be taken care by this name node so far. So that's why see we have here is see what is the job of this name node. See we have here is the role of the name node is it is responsible for maintain the index for which data is resided in which data node, because already the data is sending to this data node, isn't it? So here see what is happening, automatically from the job tracker the data is going to this data node here, fine. Then automatically here what I have to do there, if which data node is going to contains what, that actually you have to make it out. That thing can be taken care by this here. So that's why see we have mm, when the role of this name node is it is responsible to maintain the index for which data is resided in which data node, and when the application contacts the name node it tells the application as it has the data and slave computer, then the application goes directly to that node. So that's why whichever the data is there, automatically the indexing you have to maintain, and as well as all the things actually implemented with respect to this name node so far. So that's why let me come back to this. See what is the master node operations it will do with respect to this is see the role of this job tracker is please break the data into this equal number of partitions and as well as send it back to this slave computers or child computers. Now the name node job purpose is see we have here is whatever you have to maintain the index, that means which task is created, which task is implemented or processed by which data node, that kind of the indexing needs to be implemented there. So that's why these are the things you have to play there. But now see here what we have to do here. Here I have a problem, assume that because this is the thing, it is running fine, but we have lot of software failures. For suppose one node dies, then what will happen, isn't it? That also we have to check it out, isn't it? For suppose it is working fine, I have 1,000 tasks are there, 1,000 by 4 250, each and every system is processing fine. But after that I came to know that see mm, after that actually I came to know that one task is getting failed, then what will happen at that time? So that situation, see what will happen with respect to this, that is also we have to take care, isn't it? Because as we are working with respect to this, then if any software failures will happen, because see any computer will be blocked, or any computer, any slave will be crashed at any time, or some repair will happen, isn't it? So for suppose if any slave computer fails, then what will happen? What is the job of what actually the master node do at that time? That also we have to take care of that. So that situation, see what will happen. So that's why see we have when any so how to handle the hardware failures. See we have Hadoop handles the hardware failures successfully, because by default see here what will happen is Hadoop maintains 3 copies of files and each copy is scattered among different computers. So that's why see what will happen, if any system fails, it gets the data from different system and makes the data readily available. Example for this, see how it will happen. For suppose if I want to connect to any site, for suppose then what will happen, my internet is nearest place is so and so place, automate so and so, by means if I am from Hyderabad, assume that my nearest internet connectivity place is Mumbai. If the Mumbai server is dead, then automatically I will route to any other city nearby like Pune or something, isn't it? I cannot wait, isn't it? So here itself what will happen is if any slave computer fails, then automatically it gets the data from another system and as well as it will be shared among different computers. For suppose see here what is happening, see so how it will comes, let me see here. In hardware failures, assume we have 1000 requests and 250 requests are handling by each system. Then in middle, after handling 50 requests, slave 2 got failed. So after handling this 50 requests, slave 2 got failed. Then what will happen? Then master node collects the remaining requests and shares among mm, remaining 3 slave systems. Okay, so see here what will happen. Master node collects the remaining requests and shares among the remaining 3 slave systems. So then after that, see what will happen. So work can be scattered on remaining systems, and after processing 100 requests, then the client system is up. So after processing this 100 requests, then the client is up. Then what will happen? Then client gets the updated information from the master node and starts processing the remaining requests so far. So this is known as fault tolerance. This feature actually we call it here as fault tolerance. So that's why, see what will happen in HDFS, all these things are handled successfully. First, whenever any data comes, master node splits into this different partitions. So once the data is splitted over different partitions there, then what will happen? See, then once the data is splitted over different partitions, then automatically once the data is splitted over various partitions, and then the process is happening fine. So if everything goes, it's very much fine, no problem. But sometimes what will happen, hardware failures are common nowadays. So that's why if any child node fails, it doesn't mean that the 250 requests will stop. At that time what will happen is, it is going to get all the pending requests and as well as scatters among the remaining child nodes. Now after the child node is up, the child node will get the updated data, by means whichever the pending requests are there, it will get from the master node and as well as continues this one. So that's why tracking and each and everything are implemented successfully there. So this feature actually we call it here as fault tolerance. Okay, is this clear everybody? Aniteja, Rupak, Saket and Subhash, hello.
Yes.
Yeah, so this feature,
Yes.
this feature actually we call it here as fault tolerance. Okay, because these kind of the things are there, so that's why nowadays we are going to make it out. Now let us see what are the things actually the administrator will do with respect to this Hadoop there, and as well as what are the tasks can be implemented with respect to this developers that we have to see right now. So coming into the C, Hadoop will have the different things we have here as administrators. What are the things they will do? Administrators will take care of installation and as well as monitor and managing the system and as well as tuning the system. These are the things our administrators will take care of that. Where it comes to this user C, we have here is users are responsible for this design the applications, import and export the data and work with the tools. These are the things are taken care with respect to this. So these are the two jobs actually we have to make it out. Okay, is this clear everybody? Hello.
Yeah.
Yeah.
Super
Okay.
clear.
Yeah, so now this is the for today's one, but actually I have a request for you. Is this okay? Can you attend 2 hours every day? Because 1 hour actually I want to take Hadoop for some days, and 1 hour for 1 hour for Java and 1 hour for Hadoop. Is this okay for you?
Yeah, sure.
Yes, sir.
But tomorrow we will sit at the same time. Day after tomorrow onwards I will start Java. Okay, because tomorrow what I will do is, what are the elements that are there in the Hadoop that I will take, and installation also, how to install the Hadoop and as well as run it, that also I will show you. Then after that we will start both the things parallelly. Okay.
Okay.
Yeah. Okay.
Okay, sir.
Yeah, please apologize me today a bit breaks because it's a Monday here, so horrible work at office, lot of calls I got. Okay, I'm sorry for that. Tomorrow I'll make with no disturbance, please. Okay. and
Okay.
we have the classes in the weekends also. Okay, if any cancellation happens, I will inform you prior. Okay, you'll get the message from Shiva. Okay.
And you'll send the recording to our
Yeah,
mail?
recording and this whatever the notes I typed, both the things you will get to your mail, because I directly I cannot send. I will send to Shiva. From Shiva you will get the things. Okay. What I will do is
Okay.
I will create a Dropbox for your batch as Hadoop batch so and so thing. Then in this day 1, day 2, day 3, so like that I will put the folders. So the in that link automatically that link Shiva will send you. Then day wise all the materials you will get. Okay.
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 Okay. Yeah, thank you all, Mani, Rupak, and Saket, Subhash, and we'll catch up tomorrow at the same time. Okay, thank
Okay.
you.
Thank you.
And the day after tomorrow
Yeah,
onwards, our
thank you.
Java starts. Okay, yeah,
Okay.
Okay.
thank you.
Thank you. Thank you, man.
Yeah, bye.